Thank you. I don't think I could have imagined a more spectacular place to have a conference than this. This is truly amazing. What I'd like to talk to you today about is the concept that erosion costs us in many ways. Every now and then, and I'm an old guy now, every now and then I bump into somebody who goes, it's just dirt, who cares, get out of my way, I have a road to build, whatever it is. But really, there is a cost. And I've attempted in a few places, which I'll show you on the slides, to put some of those numbers on it, but the numbers, they're fictitious because every place where you build roads has its own chart and numbers that they put to it, and I can look them up and I can give you rates on them and everything, but there's so much variability in them that the exact number, don't hold me to it. Just look on it as it's a low cost, a medium cost, or a high cost, and you'll kind of know that with your experience. I do have some actual numbers later on that I have got from one of the largest home builders in the United States on what it costs when things go wrong there. So I'll go along with that. So let's move on. What if there were no rules requiring you to mitigate erosion and sediment control? What if you could just build, not have to worry about a stormwater pollution prevention plan, NPDES, an agency coming out to do anything, a SWIP inspector telling you you've got to fix this? Kind of like, you know, back in the day. I mean, they just did stuff. When you're looking at the cost of anything, there's a cost that you deal with on a daily basis, such as what do I pay for an hourly rate for a piece of equipment or an operator or materials. And then there's other costs that the people who actually account for it see, such as the costs of employee benefits, health insurance, retirement, things like that, the depreciation costs on a piece of equipment. There are costs for if the equipment is sitting there idling, if the equipment is in standby, if the equipment's being used. And on most construction sites, the average piece of equipment sits there 41% of the time not doing anything because it's waiting for some other process to get done. You can't have the bulldozer pushing everything back and forth until it's waiting for a compaction to be done, and then it has to be tested to see if it met that compaction before they push some more soil. So this whole process is an elaborate domino train where everybody's doing something and waiting and hurry up and waiting. And so as a result of that, there's all kinds of charts and information out that you can find that I looked at different things. One of the better ones I saw was an old document put out by the U.S. Department of Agriculture because they don't, the Forestry Department specifically, they don't build roads, but they have to account for and budget for roads every now and then going to a national forest or a logging operation. And so they look at everybody else's information and kind of try to sum it up. And so I looked at a 2012 one and a revised one from 2017. I'm from Florida, so I looked at our DOT. And then there's the National Highway Transportation System and all these other documents you can look at. They typically produce some type of a document. This is for a backhoe of a rate that you can calculate the monthly cost, weekly cost, daily cost, hourly cost, and everything like that. So you can get a cost for a piece of equipment. That's not difficult. And then you have to adjust it to your area because everybody has a slightly different economy. If you have a lot of windy hills like you do here, it takes longer to move a piece of equipment from one place to another or have fill delivered to your site. And there's more charts talking about on and on. Anyway, I just went through all these different numbers. You can come up with costs for different pieces of equipment, different horsepower, different sizes. They have them in different states. After a while, it became obvious there was no way I was going to be able to come up here and say, this is what it costs you to build a mile of road, because you all know more about that than me, and that was not my purpose. The purpose was to show if you're not careful, you're going to waste money. You're going to waste money with more zeros on it than I thought it was there, way more. So we get the different pieces of equipment, we get how much capacity they have, and I came up with kind of a hypothetical site and talking to some of my contractor friends of about a 5-acre site. It may be shorter in linear distance, maybe it's 1,000 feet, maybe it's less than that if it's very steep, but let's say we're working on a 4-lane highway with slopes, up gradient of the highway and then down gradient, and we have to get this thing going. And I selected at random how many pieces of equipment there would be: 2 dozers, 2 compactors, a grader, 2 dump trucks, people to operate it, some laborers because they're always needed, and we're going to have delivered at least 5 dump truck loads of fill. So it's hypothetical. Don't hold me to it. You can tell me I'm wrong later. but I had to come up with some way of comparing this. So in doing that with the costs, I selected an average chart in Midwestern US, and it came up with a cost for every piece of equipment on there, which again, I averaged, and I came up with a low number, a medium number, and a high number. So it's a range of values. And looking at that range of values, it came up with costs that an hourly cost for all of that equipment, including paying everybody, is about $1,400 to $3,200 per hour, accounting for depreciation. Oh, and I also forgot that there's also profit. There's 16% profit built into that because people build roads and as construction companies to make money. So that's all in there. And then we kept rolling more and more with different costs. And ultimately what I wanted to do is boil this down to a number, a chart. If we work on that site for 2 days, and maybe in some places they can do it in a day and a half, in other places it may take 3 days. I don't know, because every site is different. This is what you're looking at for all those costs, including making a profit, employee benefits, etc. You're looking at anywhere between almost $16,000 to almost $22,000 in cost to have to go back and regrade that site. Now, that number probably has a 25% margin of error in it. But again, you can see there's zeros on the end of that. There's a cost for having to redo something. We all know that, and construction and highway building is very expensive. I mean, I keep numbers out just for paving, like $1 million a mile just for the asphalt. So it's a very expensive business that you all are engaged in. As a result of that, in attempts to calculate how much soil you could lose, we've got different ways. This is the old one, the Russell, the Rusla, however you're going to call it, a way of calculating. It's a standard way of calculating soil loss. And again, it goes into what the average soil loss is in tons per acre per year, which includes how much rainfall do you get for your area, what type of soil you're working in. Some soils are much more erodible than others. Sand is typically more erodible than a compacted clay soil. What's your slope? I'm from flat Florida. I can't believe some of the mountains you have out here. I've been in Colorado as well. Those are going to be much more difficult to work in than a flat area. What is going to be your vegetative cover? Are you going to leave some existing vegetation? Are you going to grow vegetation? The presentation that we just heard at the beginning talked about the importance of getting vegetation established. Vegetation is ultimately what keeps all of our roadways in place, unless we're going to pour concrete every single foot of it. And there's usually combinations of this going through. And ultimately, what are our factors? What practices are we going to use? Are we going to use a rolled erosion control product? Are we using silt fence, hay, straw, mulch, compost, whatever those are? Those are all variables as well. So we can calculate the average amount of soil loss on a site. We look at the regional rainfall for an area. Again, I'm from Florida. We have very high erosive index. We get a lot of intense rain events. So our number is up between 500 and 600 for an erosive index. But if you compare that to another area, say Seattle, Pacific Northwest, they get twice as much rainfall as Florida, but it's more of a misty drizzle kind of effect as opposed to an intense tropical thunderstorm. Hawaii is kind of in the middle, parts of it in the mountainous areas. You see more rainfall event. Those are closer to what Florida sees. Parts of it on the leeward side are almost like a desert, so they get much less. So you have a lot of variability in the places you work, even out here, and you can see how that factors into it. The soil erodibility factor has been determined by scientific studies through the Department of Agriculture as a number from 0 to 1. The higher the number, the more erodible the soil. So if you had a 0.9 erodibility index, that soil will go away the first rain event you get, and you better make sure that stays covered or you get in and out there really quick. And you can look up these numbers reference. The slope, length, and grade, that's determined both by the topography of the area you're working in and what you're designing. Sometimes we decide not to go over the mountain, we drill a tunnel through the side of the mountain, or we build a bridge. In other places, we will go under things. Vegetation. Vegetation is the final cover. We want that on there. If we are inheriting a site that had no vegetation, either it's a redevelopment through an urban area, or it was typically a desert area on one side of the island, it may have difficulty establishing vegetation. We may have to choose some other cover. And again, our practices determine how much challenge we're going to have. We may completely line a drainage swale with some riprap rock or some type of a flow interrupter, as we heard earlier, or we may be looking at our sediment controls, which are put in place to slowly allow the unprotected soil to move from one compartment to another. Rainfall is the only thing you don't have control on. I always say this every conference, haven't had any takers yet. If you can control the rain, please see me on the break. I have an offer. So how do we manage this? Well, first thing we try to do is stop that raindrop from hitting the soil. It was emphasized over and over in the previous speaker's presentation, giving a push to the little raindrop. But ultimately, once that raindrop hits the soil, it explodes and loosens up any attachment that it had, and we start the erosion process. We want to minimize compaction where appropriate, because compacted soil behaves like cement, and that gives the water more energy and more velocity. Unless that's our final practice that we're going to put down for a concrete ditch or something like that, or part of the roadway, we don't want to do that to the soils. Trying to minimize the slope length means that, well, we still have to build the highway going up the roadway, but maybe we have flow interrupters, check dams, something along the way so the water doesn't run out of control. And then peak flow, we'll try to manage that by trying to get as much water as possible to infiltrate into the ground. And that's green practices, infiltration basins, things like that. So here's some math taken from the University of Central Florida's engineering department, where they were calculating soil loss for different sites. So we have a typical site here. It's about a 5-acre site, 600-foot slope, pretty flat, 5% slope. Soil is a medium erodible soil, 0.28. Remember, it's 0 to 1 is the scale. How much sediment can be lost from this site after a 2-inch rain event, 50-millimeter rain event? Will it be 24 cubic yards, 66 cubic yards, or 98 cubic yards? How many people think it's 24? It's okay, I know you're not awake. Nobody thinks it's 24, 66? Do I hear any bids for 98? Going once. Oh, got a bid for 98. All right. The actual number is 66 cubic yards can be lost from this site after a 2-inch rain event. Well, what's 66 cubic yards? 5 dump truck loads of soil be washed off of that site, either through a series of rain events or one single event. Remember, this site has no erosion controls. We're working like we used to. So boom, 5 dump truck loads of soil just went off the site. We're going to have to go back and get them. We're going to have to grade out the rill and gully erosion we have. We may have to clean out our drainage swale. Maybe we get back 2 dump truck loads. We still have to have the other material brought back in. We still have to rework it. So that's going to cost us some money. What if we take the same site and we add seed and mulch? Provide some type of cover, reduce that raindrop impact. Again, after a 2-inch rain event, what do you think our loss will be now? 0, 2, or 4? Anybody for 0? Good, there's no 0. 2? Couple? 4? The answer is 4. But remember, we went from 66 to 4. That's a 94% improvement just by doing seed and mulch, which is one of your least expensive erosion control techniques you can do. Here's a different site. This site, we have a shorter slope, 100 foot, but look how much steeper it is, 30% slope, much steeper than our 5%. Same soil, same erodibility. After 2-inch rain event, how many acres of this site do you think will lose that same 5 dump truck loads of soil? 1, 2.5, or 4? Anybody for 1? 2.5? 4? 4. 1 acre. On this much steeper site, you only need 1 acre to lose the same 5 dump truck loads of soil. So steeper sites are obviously much more challenging and require much more attention and better erosion controls than flat. So if you're not doing anything different on a flat site versus a steep site, you're not managing it. You're just kind of letting it go. All right, what if we take this site and we put down seed and straw? Now, after 2 inches, how much soil are we going to lose? 0, 5 cubic yards, or 11 cubic yards? What do you think? 5, 11, 0. Nobody thinks 0. You're smart enough to know it's not a 0. So actually, it drops to 11. That's an improvement, but that's still almost a dump truck load of soil on a steep slope. Steep slopes are very challenging. They require much more attention. Well, what if instead of doing seed and mulch, we add an erosion control blanket that has an erosivity of 0.05, a very low number? It actually is protecting it pretty well. And let's assume they put it in right, and John McCullough has some techniques. They're doing all the right stuff. So now, how much soil do you think is going to come off of this after 2 inches of rain? 0, 3, 8. We'll save you time. 3. So it is possible to manage a steep site. 3 cubic yards is something you could manage and work through. You have to still deal with it and have people making repairs and everything, but it's a lot better than losing 5 dump truck loads of soil. So again, learning and understanding how some of the properties of the different controls that you have choices on work gives you better results, which saves you time, saves you money. So in summary, be concerned about sediment yields. It is important. It does have an impact on your site. Don't leave bare ground conditions for extended times. Bare soil is your enemy. As soon as you get it sloped and get it graded, cover it with something, because if you're gambling on the weather, you're probably going to lose. You're probably going to lose, and you'll have to redo it, and it'll cost you what you think you saved in time and money. Large amounts of sediment can leave a site, especially a very steep site. Stabilize them ASAP to save that money. You have to spend money to save money, especially in this business. If you go cheap, if you buy cheap BMPs and just use them all the time, if you go back and look at your inspection reports and how much time and effort are being spent, putting the silt fence back up, reinstalling a wattle, cleaning out this thing over and over and over, you're actually losing money if you're not spending for good quality product and if they're not installed correctly. So, I got these numbers from the Environmental Programs Manager for D.R. Horton, the largest home builder in the United States. So it doesn't apply to the roads, but again, they're the costs of some of the erosion. It costs between $35,000 and $50,000 to vac truck all the sediment out of an average home-developed stormwater system, one time. In Florida and in the southeast, we have stormwater ponds. The water runs off the site, goes into the pond. They're post-construction pollution treatment, and they have to be maintained and have to be clean. If the water won't settle out because it has clay in it, then we have to do chemical treatment on it, usually using a chemical that's used in the drinking water industry, either aluminum sulfate or anionic polyacrylamide, and that can cost between $8,000 to $15,000 for the ponds. There's usually multiple ponds and multiple sets of drainage systems on a big site. Worst case scenario, you lose the whole site. We get a tropical storm. We get a series of 4 and 5 and 6 inch rain events back to back, and it blows out all their controls. You're looking at spending up to $100,000 to put the system back into compliance and clean it out one time. So this is going to be very, very expensive. This is not talking about you're being enforced on, you've got a fine, how much delay it is on your project. If you have to go clean everything else out, they're not working on anything else either. That equipment is sitting there idle, and the people are being paid to sit with idle equipment. Failure to control erosion, again, costs you time, material, and money. Vac trucks. The more emphasis you put on protecting inlets, the less you'll have to rent the vac truck. In Florida, at times, if we wash a lot of sand into our pipes and it gets into a low spot, it will compact and compact and compact to the point where the vac truck cannot get it out. It almost becomes like a cementitious material. They have to go in there with the cutter heads on it that they use to take roots out, and it's a very slow process. They cut a piece and then jet it out, and cut a piece and jet it out. So it can be very expensive, even with different types of soil that they have to clean up. If you don't maintain your inlets, you're looking at maybe losing material. In this case, this goes into a stormwater pond. In Florida, where we have sandy soils, these are infiltrating basins. You may construct some here in some of your porous soils as well. If you fill them up with clay and that material goes into the open pore spaces between the sand grains, guess what you've created? A solid pond with no exit. And in Florida, within 72 hours, you'll start breeding mosquitoes, and you'll have an issue with the Department of Health. So it can have impacts above and beyond what you think it can do. If we do chemical treatment on a pond system, first we have to get a sample of the water, then you have to do a jar test so they know the dosage to put for the alum or the polyacrylamide in there. Then you have to pay an operator to go out and apply the material, then you have to do testing and make sure that it's back to the original clarity that the pond was before. Failure to control erosion can have impacts on the edge of the road. Usually where hard meets soft is where we start seeing erosion. We start chipping away at the edge of the roadway here, and we start seeing little pieces calve off. This can incise along the edge of the road, destroy the apron on the side, and again, require us to have to go back and deal with it. If this continues unabated, it will get worse. This was only about 1,000 feet from where I live. So some of the worst stuff in Florida occurs close enough where I don't have to go too far to get these great pictures, unfortunately. If you can leave conditions like this and there's an accident, somebody gets in an accident, they hit the pothole, they don't see it, they run off and they get injured. Now you're looking at lawsuits. Lawsuits are not $100, $1,000. They're hundreds of thousands to millions of dollars. They may be open-ended. So again, there can be other issues associated with not paying attention to the erosion. Again, water travels downhill. It starts to cause impacts to other systems, clogging and changing the direction of the flow of our drainage systems. Here is a community along a roadway that had erosion that wasn't addressed. It washed open the exposed power lines. These are 15,000 volt power lines that are supposed to put on the electricity inside of the new homes. Well, it washed them out. Well, they had to stop the road. They had to bring out people to do the inspections, make sure that there weren't any damage to the cables. They had to turn off the power to the phase one people living in the development. They were not very happy to not have electricity for 48 hours, all because the road development here didn't pay attention. Again, we want to catch these problems that the inspectors may show up early. These are maintenance problems. We want to move on. You don't want to wash everything into the drainage systems because then you're going to have to hire a piece of equipment to go clean it up. Try not to let everything get to the point where it's catastrophic, where we blow out hardscape, where we cause pipes to fail and come apart. Again, erosion control costs you time, material, and money. Failure to control it. And that's all I've got at this point. So I hope I've hit that point over and over. Many of you see this, but we become complacent. We're just used to seeing. There's always a little bit of soil at the bottom of the hill. There's always a little bit of washout here. Try and manage and ask, where'd that come from? Can I stop it? Is there something else we can do? And you'll start saving money that adds up more and more and more, and you'll be more effective in your projects so that you guys can do what you want to do, which is build roads. You don't want to chase dirt. You don't want to chase mud. You don't want to be in the public eye for contaminating the name of, insert name of lake here. You want to do what you want. You want to provide transportation to everybody. So that's all I've got. If there are any questions, I'll take them now. If not,